Alright, this is the 8.2 homework set. Once again, I'm just giving you some examples from the homework just to save us some time. So what you're doing in 8.2 is you're doing these maximum and minimum problems based on these linear constraints that we were given. Again, what we're basically trying to do, these constraints create this shaded region, just like in the last homework set. We're basically coming up with this shaded region, but now we're going one step further. We're saying, alright, here's our objective function that we're trying to either maximize or minimize subject to these constraints. And the way this works is these endpoints of your region are where the maximum and minimum possible values could lie. Alright, don't forget this one right here. Okay, 0, 0 is also one of these corner points on this region. So the maximum possible value for the objective function, if I bring my calculator up, what this is basically telling me is this function right here, 5x plus 7y, is maximized and or minimized at one of these 4 points. Alright, so I'm going to plug in 5 parentheses where the x is going to go. Alright, and I'm going to just start with this point. So x is 0 here. 0, close that parentheses, plus 7, and then y is 36. And close that parentheses, hit enter. So there's one possible value of this function. Now, do it again. I can hit second, enter, bring back the last thing I just did, and now I'm going to change this from 0 to 30. I'm going to try this other point. So 30, insert parentheses, and then the 36 I'm going to change to a 26. Alright, 332. So far this is lower, so the maximum right now is this one. Alright, do it again, this time picking this number, or this point. So x, remember x is beside 5, so x is 69 here, and y was beside the 7. Y is a 0. Okay, I already have a double digit number in there, so I can just throw in a double 0. 345. So now this is a little bit bigger. Alright, and then again, you always need to check the double zeros. And that's also one of the endpoints of this region. So 0 for x, 0 for y, obviously that's going to make it equal to 0. Alright, so the maximum possible value for the objective function is 345 according to this. Now the way this works, these max-min problems, when you're doing this linear optimization, it can't be in the shaded region. Right? So like 20, 10, that's just not going to work. Okay, it's not going to make it higher than that. If I pick 2010, which is in that shaded region, as a point in that shaded region, it's guaranteed that it's not going to be higher than 345. Okay, because these boundary regions are where it's going to be maximized and minimized. Alright, so the maximum possible value was 345, and the minimum possible value, the lowest we got, was 0, 0. Alright, when we were at that point. And don't forget that point. Okay, these others have the dots there, so a lot of times people just ignore that that's on there. But x can be 0, y can be 0, so that is also a corner point in the shaded region. Okay, but your maximum min values are always going to be a corner point where this thing takes a turn in one direction or another. Alright, same idea here. I'm going to take this objective function, 12 parentheses, and I'm going to plug in all the different x's and y's. Alright, so 12x, I'll start with obviously 0, 0. I need to pick again because it's on here. 12x plus 4y. Right, that's obviously 0, and then just make my way around to the other values like 0, 2. Second enter will bring back the last thing you just did. Change that from 0, 0 to 0, 2. So I get 8. Three, 5. I'm just making my way around this way. Alright. 5, 4. Alright, now I'm getting ready to lose that 0 on there, so you may want to just jot down something like, you can hit second parentheses to make a set and say 0, 8, 56, 76, and you can kind of keep track of your numbers as you go. Alright, and then hit second enter a couple times, and that'll take you back up to the original, and we can continue. Alright, 6, 0. Alright, it's 72, and then we made our way around. Alright, so there's our numbers: 0, 8, 56, 76, and 72. So what maximized it? 76. That's the highest that we can get. Alright, and the minimum value, again, if I look at all these values, 0, 8, 56, 76, 72, 0 is again the lowest. Now 0 won't always be the lowest, just depends on your objective function. Okay, but if it's linear like this, if everything's increasing left to right, then a lot of times that will be the lowest. But you always need to check all 4 of them like that. Alright, this particular problem, they don't give us the regions, and they don't give us the turning points on that region. So we have to come up with it ourselves. So again, this is going back to the last homework set in 8.1. So what you want to do here, let me clear out all these examples from another class. What you want to do here is you want to isolate the y in these restraining equations, or constraint equations. So if I isolate this y, I just need to bring that x over. So that's going to be 7 minus x. And then if I want to isolate this y, I bring that x over, so that's 4 minus x. Okay, and then remember your window, x is greater than 0, y is greater than 0. So I'm going to change this to 10, x scale 1, change that to 10, y scale 1, and just see what we have so far. Oh yeah. And remember, sorry, when this is positive, this is less than. Remember, scroll over here, hit enter a couple times, 3 times, and that'll change this to less than, shading below. Alright, this is the y equals 4 minus x. This one, it was a greater than. This is positive, so we'll shade it greater than. Oops. Okay, and then I've got my window set to be x above 0, y above 0, so I hit graph. And remember, we're looking for what's shaded in both directions. Sorry, in both of these things. So this region right here between the 2 lines is what I'm looking for. Okay, now hit trace. We can find where it crosses here just by hitting trace and hitting 0. So that's 0, 7. That's one thing we need to test. Alright, so here I'm just keeping track of my test points. So 0, 7 is one of them. Alright, now I'm in y1. If I hit down, I'll go to y2, and then obviously 0, 4 is another test point. That's the y-intercept of that other line. Alright, and then I need to find these X intercepts. Okay, so if I have y equals 4 minus x, and y equals 7 minus x. These are the two equations that I have. If you recall, this is what I've got stored in my y1 when I isolated the y's. 7 minus x and 4 minus x. If I want to find the x-intercepts, I make y equal to 0 in both of these. Alright, and then just isolate the x. Get the x over there by itself on both of these. Oops. By adding it to both sides and both equations. And I got obviously x equals 7 and x equals 4. Okay, so that means 7, 0 and 4, 0 are also test points on here. Okay, so 0, 4, 4, 0, 0, 7, 7, 0, and that's the boundaries of this region. 0, 0 does not work here. Okay, it's not in the shaded region, so it can't be a value. Alright, now go back to your main screen. There's our objective function, 7x plus 8y. So 7, one of our points was 0, 7x plus 8y, 4. Alright, 0, 7. And then switch the x's and the y's. 7, 0. Right, and then lastly 4, 0. So there's our 4 points that we got to check out. Alright, 32, 56, 49, 28, 56 is our maximum. So the maximum value of z is 56. Alright, and it occurs at the point, remember this was our x, this was our y, so it occurred at 0, 7. Alright, so if you have to find it, you just have to go through and find out what those endpoints of the shaded region you come up with are. Alright, here's one with 3 linear constraints. So let's go through to this one. Alright, again, you want to be able to use your calculator to help you, that is. You want to get all these things that have x's and y's, you want to get the y isolated. Okay, so if I'm doing this, if I want to isolate y in x minus y less than or equal to 7, if I want to isolate this y, I'm going to subtract x, and I get negative y is less than or equal to negative x plus 7. Okay, but then I have to divide away the negative. Alright, so I get y, and then this is going to switch signs. Remember, when you divide by a negative, it flips around. A negative x divided by negative 1 is a positive x, and then positive 7 divided by negative 1 is negative 7. Alright, so I'm going to use x minus 7 in there. Alright, y is isolated, so this is a greater than, so I'm going to use that. Alright, back over here. The next one I've got is 19x plus 14y is less than or equal to 266. Okay, so bring the x over first. So 14y is less than or equal to 266 minus 19x, and then I'm going to divide by 14. Now, when you use your calculator, you can literally just put it in there like that. If you're using your calculator to help you, put the parentheses in there, 266 minus 19x, alright, divided by 14. You don't have to get it like into some y equals mx plus b form or something like that. It's fine if you just put it in there this way. Okay, y is isolated. This is a less than. And we have y isolated, so we're going to use that one. Alright, and then the next one I've got 17x plus 20y less than or equal to 340. Same thing, subtract the 17x, 20y is less than or equal to 340 minus 17x divided by 20. Alright, and then just remember to use your parentheses when you put in your calculator. 340 minus 17x is all being divided by 20. And once again, this one is a less than. Alright, and then once again we have the x greater than 0, y greater than 0. Alright, now this time we'll have to play around with our window a little bit. Alright, using the last window, the 10 to 10, we don't see a definite region. We don't see all those turning points of this solid region right here, so we need to play with our window. Alright, I'm going to change this to 0 to 20. Alright, I'm using x scale 5, you can leave it 1. And then my y is also going to go from 0 to 20. Alright, and then when I graph it this time, notice here's the first thing I'm graphing. Here's the second. Okay, and we see that intersection. And then here comes the third. Alright, now this is not that easy to see when we have a third one come in there. Right, but if you follow this line, and let me just paste this into this window over here. So this is what my calculator screen has here. Now what I need are these turning points on this thing. Now the ones that are easy to find, or relatively easy to find, I guess I should say, are the origin again on this particular problem. Okay, this one right here where this line hits the x-axis. Alright, this right here where this line is coming down right here, crosses this line. Okay, and then as you follow this up where this line crosses this line, alright, and then where this line hits the y-axis. Alright, so that's our region we're looking at in this problem. So it's this funky pentagon shape. So we've got to find those those 5 points. Now I can find this one. This one's pretty easy. This one's 0, 0. Right, but we need to know which line is which. So go back to your calculator, hit the trace button, and notice that it still tells you which line you're on. So I can scroll back and forth. This is the line y equals x minus 7. So this is y equals x minus 7. It's important that you know which line is which when you're doing all this. Alright, the y2, that's that line right there. Okay, that's 266 minus 19x over 14. That's this one right here. Okay, and then that leaves this one to be the third one. 340 minus 17x over 20. Alright, now why is that important? Because these points are on these lines. Okay, this point right here, the next one we're looking for, is the x-intercept of this line. So the x-intercept of this line occurs when y equals 0. So add 7 to both sides. X equals 7. So this right here, this second one from the origin, is the point 7, 0. Alright, this point right here is the intersection of x minus 7 and this line. Now we can use our calculator to find it. We don't have to do it by hand. We could, but we can also use our calculator. So I'm going to use second trace intersect. Alright, now what am I intersecting? This is where first curve, second curve actually is important. Normally we just hit enter because we're only looking for two things, but we have three functions here. So we want to know where x minus 7, that's our first curve, intersects 266 minus 19x over 14. That's our second curve. Hit enter, and then our guess looks like they hit, as you can see my cursor right there. Hit enter, just get it close and it'll find it. So 11.03 and 4.03. I'm going to write that one down here. Alright, now this point right here is the intersection of this line, 340 minus 17x over 20, right, and that 266 minus 19x line. So we're going to go back to our calculator. We want the intersection this time of not y1 this time, but y2 and if you can see it, there's y3. So we want the intersection of those two, which occurs roughly right in there. Alright, so 3.94 and 13.65. 3.94, 13.65. And again, I'll write that one down here as well. Just another test point. Alright, and then the last one, we've got 4 of the 5 points. The last one up here is the y-intercept of this 340 minus 17x over 20 point. So I can hit trace, press 0. Alright, this is the y-intercept of y1. That's not what we want. There's the y-intercept of y2. Again, that's not what we want. And then finally there's the y-intercept of y3, and that's the one we want. So 0, 17. Alright, so there's the points we're going to try. So there's 1, 2, 3, 4, 5 test points that we're going to try. Alright, now go back, get our 4x plus 5y function. Alright, let me bring this back up. 11 11.03 x plus 5, y is 4.03. So there's one of our numbers. Second entry to get it back. Alright, 3.94, I'm going to write it as 03.94, so I don't have to delete or insert anything as I go along. Plus 5 times 13.65. Alright, there's another one. 84.01. Once again, now we're going to do it with some of the zeros. Alright, so 0, delete, 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 delete. I'll do a double 0 for that. I don't need a double digit. And then 5 times 17. Delete, delete, delete. 85. Alright, and then getting ready to lose the 64, so I'm going to write it 64.27, comma 84.01, comma 85. So those are the three I have so far. Second parentheses. Alright, and then second enter 2 times to get back to the function you've been working with. Alright, obviously 0, 0 is going to give me 0, 0, so I'm going to use 7, 0 and be done with it. Alright, 28. So there's my numbers. We want to maximize that. So the maximum value occurred at 85. Alright, 85 occurred when x was 0, y was 17. Alright, so sometimes they're a little bit more complicated, but use that intersect feature, right, and keep a good track of what you're using. Right, and your calculators are a really good tool in this section as long as you know how to use it and how to get to those test points.